Day 550 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3318. Find X sum of all K-long subarrays 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array nums of n integers and two integers k and x. The x sum of an array is calculated by the following procedure. Count the occurrences of all elements in the array. Keep only the occurrences of the top x most frequent elements. If two elements have the same number of occurrences, the element with the bigger value is considered more frequent. Calculate the sum of the resulting array. Note that if an array has less than x distinct elements, its x sum is the sum of the array. Return an integer array answer of length n minus k plus 1, where answer of I is the x sum of the subarray nums of I all the way up to I plus k minus 1. All right, y'all, so I understand how that could be a little bit difficult to understand. So let's go ahead and take a look at these examples to make sure we are doing this problem correctly. Now, before we get into example 1, the first thing we want to understand is what is a subarray. It says a subarray is a contiguous, non-empty sequence of elements within the array. So all this means is a subarray is like an array that we can create inside of the array, right? And all of the elements need to be contiguous, meaning they're all next to each other. We can't just delete some elements. There's not one of those questions where we can delete some elements. This is all of the elements in the subarray need to be contiguous like this, all lined up next to each other. We can't just pick this one and then this 3 and then this 2. No, they have to already be lined up, right? Like this. These would be different subarrays. Boom. Then we need to understand how our output is going to work and how to find these subarrays. So it says the answer of length n minus k plus 1. So in this case, you can see the answer is of length 3, which when you do this calculation, you can see that it's n minus k plus 1. So in this case, n would be 1, 2, 3, 4, 5, 6, 7, 8. Boom. Then 8. So it would be n minus k. So 8 minus 6, it would be 2. Then plus 1 would be 3. So that's why our output has 3 elements right here. We also need to figure out how we are going to find the subarrays that we're going to use. So it's going to be the x sum of the subarrays nums of I all the way up to I plus k minus 1. So what that means is, so in this case, say this is I, right? All the way up to I plus k. So I plus k would be, if this was I, which would be 0, plus k would be 6. So we go all the way up to 0, or 1, 2, 3, 4, 5, 6, right? But then it says, it'd be 0, 1, 2, 3, 4, 5, 6, right? But then it says minus 1. So we have to come back just to 0, 1, 2, 3, 4, 5. And so it stopped right here. So as you can see in the explanation, it stops right here because it goes from index 0 to index 5, right? Or we could just say 0, comma 5 because it's 5 from. So the subarray our first subarray that we would be using would be 0 through 5. So it'd be 0, 1, 2, 3, 4, 5 once again. Boom. And that's how we got this first subarray right here. Then similarly, if we started at index 1 and we keep going down and now I equals 1, that'd be all the way up to I plus k minus 1. So that'd be I plus 6 would be 7 minus 1. So it'd be 1 to 6, where this is just moving down. Where this was 0 to 5, the next subarray would be 1 to 6. Boom. And then it go 1, 2, 3, 4, 5, 6. Boom. And then that would be this subarray right here. And then so on until we move down until this is the array. Boom. So now that we understand completely what the question is asking, let's take a look at example 1. So in example 1, we have the input nums equals an array of integers 1, 1, 2, 2, 3, 4, 2, 3, k equals 6, and x equals 2. So the x, it says right here, sorry y'all, it says note that, we want to keep only the occurrences of the topmost x frequent elements, right? So in this case, x equals 2, so we want to keep the occurrence, or we want to keep the occurrence, or we want to look at the occurrence of the top 2 most frequent elements. So let's keep going. So the output will be 6, 10, and 12, right? So it says for the subarray 1, 1, 2, 2, 3, 4, which would be this first one, what I showed you, which was 0 to 5, right? So for 0 to 5, for the first subarray, only elements 1 and 2 will be kept in the resulting array. Hence, answer of 0 will be 1 plus 1 plus 2 plus 2. So let's break that down one more time, right? So once again, x equals 2. So we want to look at the elements that appear the top 2 most amount of times, which in this case is 1. Sorry, y'all. 1 appears twice and 2 appears twice. So these 2 elements appear the most amount of times. These are the top 2 most appearing elements in this array, right? We're not looking at this whole array. We're only looking at this array right here, and 1 and 2 appear the top 2 most amount of times. So that's why for answer 0, for our first answer, we're just going to do 1 plus 1 plus 2 plus 2, which is going to give us 6. Now that's just the first answer, right? Or answer of 0. We still have more to go, because remember, the answer array needs to be of length n minus k plus 1. So in this case, once again, n minus k plus 1 would be 8 minus 6 plus 1, which would be 3. So we need our output array to be of length 3. Right now, that's just how we got our first one. So now we're going to keep going. Now we're going to move I down to this array. Now we have a bigger subarray, or not a bigger subarray, but we're moving on to the next subarray. That's how we got this first answer. This next subarray is how we're going to get this second answer, right? So it says for subarray 1, 2, 2, 3, 4, 2, only 2 elements, and only elements 2 and 4 will be kept in the resulting array. Hence, answer of 1 is 2 plus 2 plus 2 plus 4. Note that 4 is kept in the array since it is bigger than 3 and 1, which occur the same amount of times. So now we are looking at this subarray, right? And in this subarray, we have 2 appears twice. 2 appears 3 times. It appears right here and right here. Boom. Or we could look down here. It appears right here and right here. Boom. And then 1, 3, and 4 appear once. But it says right here, the element with the bigger value is considered more frequent. So since 1, 3, and 4 all appear once, we want to pick the element with the biggest value. And in this case, 4 is greater than 1 and 3, so it has the biggest value. So that's what we're going to use in our output. So then when we add 2 plus 2 plus 2, that's going to give us 6. Then plus 4, that's going to give us 10. And that's how we got this 10 for our second element in our output array. Now we still need one more, because remember, the length needs to be of count 3. So for the next subarray, we're just going to move it on down, and it's going to be this subarray, right? And this right here. Boom. So for subarray 2, 2, 3, 4, 2, 3, only elements 2 and 3 are kept in the resulting array. Hence, the answer of 2 is 2 plus 2 plus 2 plus 3 plus 3. So in this array, you can see the top 2 appearing elements are 2. We have 3 2s, so they appear 2 appears 3 times, and 3 appears twice, right? And then 4 appears once. So since 2 and 3 are the top 2 most appearing elements, those are the elements we're going to look at. Then we're going to add them together. When we add them all together, we get 12, and that's how we got an answer of 12 right here. Now, I know that was a little bit confusing, so let's take a look at example 2. Same principles apply. So in example 2, we have the input nums equals an array of integers 2, 3, 7, 8, 7, 5, k equals 2, and x equals 2. So in this case, on the output, it says 11. The output is an array of integers 11, 15, 15, 15, and 12. explanation, since k is equal to x, answer of I is equal to the sum of the array I through I plus k minus 1. So in this case, k and x are both equal to 2, right? So since k is equal to 2, now we do, say we want to find how long this our output array would be. So our output array is I through I plus k minus 1. So it would be 0, or excuse me, yeah, 0 through I plus k would be 0 plus 2 would be 2 minus 1 would be 1. So it would just be these right here. Boom. And then we want the top two, right? So then the top two, there's only two. That's what it means, since k is equal to x. We want the top two. We're just adding these together. So 3 plus 8, that's 11. Boom. Sorry, that's 11. Then we keep moving down. 8 plus 7, that's 15. Boom. Then 7 plus 8, boom, that's 15. Then 8 plus 7, boom, that's 15. Sorry, y'all, 15. And then 7 plus 5, boom, that's 12. So same principles apply. It was a little bit easier just because k is equal to 2 and x is equal to 2. But once again, the same principle. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not too difficult at all. Now, the first thing we want to do is we want to create our array, or our output array, that will store the final list of computed sums for each window. So we're going to say declare variable called result. We'll say colon. It's going to be an array of integers, and we'll initialize it with a blank array like that. Boom. Then the total number of elements in nums, we need to get that. So we're going to say let n equal nums.count. Boom. Now we need to slide a window of size k across the array, and the loop runs until index 0 to n minus k. So we're going to say for I n 0 dot dot dot, open up the parentheses, n minus k, come outside of those parentheses, and we are going to open up the brackets, and we're going to extract the subarray of length k starting at index I. So we're going to say let sub equal an array, open up the parentheses, pass in nums, square bracket I, dot dot less than I plus k. Boom. Now we need a dictionary to store the frequency of each number in the current window. So we can come underneath this, and we can declare a variable called freq, say colon. It's going to be a dictionary of integers. The key is a dictionary. The key is an integer, and the value is an integer. And we can initialize it with a blank dictionary like so. Boom. Then we're going to count the number of occurrences of each number in the current array. So to do that, we could just say for num n sub. We're going to open up the brackets, and we're going to say freq square bracket num comma default colon 0. Come outside the square bracket, we'll say plus equals 1. So each time we see num, this num and sub, each time we see one of this num, right, we're going to store it right here in this dictionary, in this freq dictionary right here. So we're going to store num on this side as the key, boom, and then we're going to keep count on this side as the value, which is right here. So each time we see this number over here, we're going to keep count over here, starting the count from 0. So the count is going to start from 0. That's what this default 0 means. And then each time we see that number, we're going to increment it by 1 to this count. Boom. Now we need to sort the frequency map, first by descending frequency, so the higher count will come first. And if two numbers have the same frequency, we're going to sort by descending number value. So we'll come underneath this for loop right here, and we'll say let sorted equal freq dot sorted. We're going to open up the brackets. We're going to say if $0 dot value equals $1 dot value. We're going to open up the brackets, and we're going to return $0 dot key is greater than $1 dot key. Boom. Then we'll come underneath this if and we could just say return $0 dot value is greater than $1 dot value. Boom. Then we're going to take the top X elements from the sorted list by coming right here underneath this let, and we're going to say let top X equal sorted dot prefix open up the parentheses X. Boom. And for each key value pair, we're going to compute key times value and sum them up. And this is going to represent the X sum for the window. So we're going to come underneath this. We're going to say let sum equal top X dot map. Open up the brackets. We're going to say $0 dot key times $0 dot value. Boom. Then we'll come underneath this and we'll say let add equals sum dot reduce. Open up the parentheses. We're going to say 0, comma, open up the brackets, $0 plus $1. Boom, just like that. Still not done. Still got to keep going. We're going to append the computed sum of this window to the result array by coming underneath this, and we're going to say result dot append, open up the parentheses, pass in add, and then we're going to return the list of computed sums for all windows by coming right here, and we're going to say return results, y'all. Boom, that should be all she wrote. Let's give it a run before we submit it. Make sure it runs correctly. Okay, and we have an error already. Cannot find num. That should be nums. Let's run it again. See if that does the trick. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 11 milliseconds beats 33.33% of users. Not too bad. We could definitely get those numbers up. But right now, I just wanted to present y'all with a solution that's easy to understand and easy to learn from. Because if you don't understand the solution, then you probably didn't learn anything. And I feel like this is an easy solution to understand. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.